Good morning, everyone. How are you guys doing today? So we are very close to the end of the semester. I think we have only, this week we have 2 classes, including today. Next week, 3, and then 2. So 7 more classes, including today. And then it will be done. Yay. So on our last class, we started chapter 11. And we are going to take today, tomorrow, and next Tuesday on chapter 11. Thursday, we are going to have a review. And your exam 5 will be on Friday. If you haven't noticed, I already posted the review sheet on Brightspace. All the questions in the review sheet are from the lecture notes. So try them by yourself. And if you get stuck, just look at the lecture videos or your notes. You'll be fine. Okay, any question from anyone before we start? Any comments, concern, complaint? Nothing? Okay, then let's start with the last materials we talked about in our last class. We said first we learned how to solve for x using complete the square method. If you don't like that method, then your next hope is quadratic formula. Quadratic formula has 2 downsides. One, you must remember it correctly, otherwise it's over. And second, you cannot use quadratic formula for bigger numbers. When you have a, b, c bigger, that means you get a big number under the square root and then you get stuck. So quadratic formula is easier with the smaller number, and if you can remember the formula correctly. However, without even solving the entire x, just by observing what we have under the radical, we can already figure out how many solutions we are going to get. And the thing we have under the radical, we call them discriminant. Discriminant tells us how many solutions and what type of solution we have. So if discriminant is positive, we get 2 real solutions or 2 x-intercepts. 2 real solution means the solutions we have, we can see them. So we are crossing the x-axis twice. So maybe you have a scenario like this, or maybe you have a scenario like this, where you are crossing your x-axis twice visibly. So we have an upward parabola if your leading coefficient is positive, and we have a downward parabola if the leading coefficient is negative. For example, this is positive x squared, and this is negative x squared. And when we have our discriminant 0, exactly 0, that means we have 1 real solution. It means we are crossing the x-axis or we are touching the x-axis only once. So we have 1 x-intercept. So either you have something like this, or this, or you have something like this, or this, or this. You're touching your x-axis only once. And again, this is for positive x squared, this is for negative x squared. And lastly, when your discriminant is a negative number, it means you have a negative number under the square root. As a result, you have 2 imaginary solutions. And since these are imaginary, not the real solutions, that means you're not crossing the x-axis directly. So we get no x-intercepts. X-intercept has to be real, and we get the x-intercept when you cross the x-axis. for the imaginary numbers, we cannot cross, we do not cross the x-axis. So we have maybe something like this. Point we have positive x squared, or we have something below the x-axis, point we have negative x squared. So in the final exam, sometimes they ask you a question like a quadratic equation has discriminant 45. How many and what type of solution it has? That's why we need to know these things here, because you may see this in the final exam. There are a few examples. It says use the discriminants. That means you have to know what is discriminant. Discriminant is a thing under the square root. And so when you use the square root, we simply take the terms we have under the square root. But yes, you can use the square root, no problem. Now use that to find out how many solutions you have and what type, are they real or are they imaginary? And also talk about the x-intercept. So we start by, in order to use discriminant or quadratic formula, the condition is you have to have all the terms on one side and the other side is 0. You must have to have that format. So discriminant is b squared minus 4ac. That means you have to identify in a given equation what is a, b, and c. So what is a here? 2, b, 1, and c, 2. So b square means what square? 1 square minus 4 times 2. So we have 1 minus 2 times 2 is 4, 4 times 4 is 16. We have 1 minus 16, that gives us negative 15. That means we found our discriminant is negative. So how many and what type of solution we have? 2 imaginary solution. And how about the x-intercept? How many x-intercepts we have? None. Because these are imaginary. No x-intercept. You don't have to memorize this as long as you know what you're doing. Discriminant is negative. It means you have x equals negative b plus minus square root of 15 over 2a. This is what it means for discriminant to be negative. Now you can see we have two solutions. We have negative b plus 15 under the square root I over 2a, and negative b minus square root of 15 under the square root I over 2a. So this is 1, this is 2. We have two solutions and both of them are I. So two imaginary solutions. You don't have to memorize as long as you understand your discriminant portion. Question? Okay, then you try the next two. Condition to use quadratic formula. One side has to be 0. So use the discriminant to figure out how many solutions you have and what type. And what about the x-intercept? Ready? Ronaldo, what is your first step? In order to use the quadratic formula discriminant, what's the condition? You have to see 0 on one side. Do you see 0 on one side? Step 1 has to be putting everything together. So negative x squared plus 3x plus 5 equals 0. And now what is our A? B positive 5. So what is discriminant? AC. So what do we have in our case? Three square negative 1 positive 5. Excellent. What is 3 square? And then negative 4 times negative 1 times 5. Negative times negative will turn into positive. And then 4 times 1 times 5. 4 times 1 is 4. And then 4 times 5 is 20. And what is 20 plus 9? 29. So our discriminant is positive. How many and what type of solution we have? Two real solution. And how about the x-intercept? 2 x-intercept, because two real solution means you're crossing the x-axis twice. 2 x-intercept. Eliza, no phone. Okay. Camila, the next one. So minus 4x minus 4x. We have x squared minus 4x plus 4 equals 0. What is our A? 1, B, positive or negative? Negative 4, and C, 4. So discriminant is B squared minus 4AC. That will tell us it's 1 squared minus 4 times. Wait, B squared, what is our B? So it's negative 4 squared. 4 times. What is negative 4 squared? 16. So 4 times 1 times 4. 16, right? 4 times 1 is 4, and 4 times 4 is 16. So what is our discriminant? So how many and what type of solution we have? Real or imaginary? One real solution. That means we have one x-intercept. That's it. Thank you. Any question from anyone? Again, if you cannot remember Just replace everything to the quadratic formula, and then you will see what type of solution you have, and are they real or imaginary. As long as they're real, you have a x-intercept. If they become unreal, imaginary, you don't have any x-intercept. With this, you're done at 11.2. Now you're going to do 11.3. 11.3 is a fun section. It's fun because all the questions you see, they seem so hard, but actually they're very easy. So in this section, we are going to talk about some function. They don't look like quadratic, but we can use quadratic methods to solve them. What do I mean quadratic methods? Quadratic method means either we can factor and solve, or you can use the complete the square method and solve, or you can use the quadratic formula and solve. So whatever way we can solve a quadratic equation, we can solve this weird looking examples same way as quadratic, how you solve quadratic. For example, if you have radical equation, rational equation, those, they don't look like quadratic, but as long as they satisfy one condition, we can solve them using quadratic. But it has to have a condition fulfilled. What's the condition? The condition is that the two powers you have in an equation, one of the power has to be twice the other power. As long as you fulfill this condition, yes, you can treat them as a quadratic and you can solve them. For example, here, these look so hard looking questions, right? But look here. One power is 1/5, the other power is 2/5, right? The two powers we have. So if you multiply the smaller one by 2, do you get the bigger one? What is 2 times 1/5? 2/5. So do you have both of them here? Twice the smaller power is the bigger one. We have, right? So we can solve it using quadratic method. Look at the next one. The two powers are 1/3 and 2/3. So if you multiply 1/3 by 2, what do you get? 2/3. So your condition fulfilled. 1 power times 2 gives us the other power. Look at this one. 1 is 2 power, 1 is 4 power. If you multiply the smaller one by 2, 2 times 2, do you get the bigger one? So you can solve it using quadratic. Look at this one. 1 power is 3, the other power is 6. If you multiply the smaller one by 2, do you get the bigger one? Yes. Now look at this one. We have -2 and -1. If you multiply -1 by 2, do you get the other one? No. Yes, -1 times 2 is -2. So you can solve it. Look at this one. This base has power 2. This base has power 1. So if you multiply this 1 power by 2, do you get the bigger power? So you can solve it using quadratic. So all these, they look very hard, but actually they are not hard. Why not? Because they follow the quadratic format. But the quadratic format also says, in order to solve, you have to have 0 in one side. That's the rules for quadratic. I mean, you don't have to, but we want to, because our goal is to factor them. So since we don't have a 0, our first step is bring things from right to the left, so that we have 3 terms together, so we can factor. Second condition. Have 0 on one side. So subtract 4x to the 1/5 from both sides, and we get x to the 2/5 minus 4x to the 1/5 plus 3 equals 0. So we have 3 terms, and if you multiply 1/5 by 2, we get 2/5. So it follows the quadratic format. This is same as you have x squared minus 4x plus 3. similar to x squared minus 4x plus 3 equals 0. They don't look like it, but they have the same format. Whatever power we have here, the first one has twice the same amount. So we know how to factor x squared minus 4x plus 3, right? Which two numbers multiply to 3 and combine to 4? If you factor two numbers multiply to 3 combine to 4, what they will be? 3 and 1. And we want negative 4 from them. Both negatives. Now, if we were factoring these, what would we have done here? X. But now we don't have any x, we have x to the 1/5. So we are going to place x to the 1/5 in the middle term in both cases instead of x. X to the 1/5. And you can check, if you multiply x to the 1/5 times x to the 1/5, in multiplication we add the powers, so you get x to the 2/5 the first term. So you're splitting the first term into two pieces, and you're splitting the last term into two pieces. And then how do you solve from here? What do you do next? We set each of them equals to 0, just like we did before. Take your x to the 1/5 minus 3 set it equals 0. X to the 1/5 minus 1 set it equals 0. Let me do it here. We add 3 and 1 to both sides. So we have x to the 1/5 equals 3 and x to the 1/5 equals 1. And now we're almost done. The only problem is the 1/5 power. We don't want to see the 1/5 power. So what can you do so that the 1/5 power becomes 1 power? Your idea is okay, but look at the 1/5 power. We want this 1/5 to become 1. So what can you do so that 1/5 become 1? By? It can only multiply, but you can multiply by what? 5. If you multiply by 5, the 5 and 5 denominator cancel out, you get 1. In other words, all you have to do is apply the 5 power on both sides. So 1/5 and 5, they will cancel out. We'll have x with 1 power, which is a single x. And now you have to multiply 3 5 times. So 3 times 3 times 3 times 3. 3 times 3 gives us 9. 9 times 3 gives us 27. 27 times 3, 81. And now lastly, 81 times 3, 243. So one of the x values is 243. We do the same thing here. We apply the 5 power. So 5 power and 5 denominator cancel out. We get a single x. And if you multiply 1 5 times, what do you get? Still 1. So remember the exponent rules. 1 to the any power is 1. So here we have 5 power, but we still get 1 back. That's why we love this type of questions, because they look hard, but actually they are not hard. All you have to do is look at one condition. if you have 3 terms or 2 terms and the smaller power is bigger than, smaller power is twice the bigger one. No, bigger power is twice the smaller one, then you can factor and you can solve. Question? Not irrelevant. Look what happens x to the 2. We split x to the 2 into 2 pieces. X to the 1 field and x to the 1 field. So if you put them together, they become 2 fields. So we break this down into 2 pieces and we break this down into 2 pieces. And that's how we got our 2 factors. So after the -4, that's about to -4? Yeah. So we are looking for 2 numbers multiplied to +3 combined to -4. Because we are factoring them. What are the 2 numbers? -3 and -1. When you add them, -3 and -1, you get -4. Just like factoring this one. So let me show you this one so you'll see what we did. So if we had this question, x squared minus 4x plus 3 equals 0, we know the answer is x minus 3 and x minus 1 equals 0, right? So from here, x minus 3, 0 gives us x equals 3, and x minus 1, 0 gives us x equals 1. So see, if you had only x squared, we splitted this x squared into 2 pieces, x and x. So x times x gives us x squared. For the 3 times 1 gives us 3. So we splitted the 3 and we splitted the x squared. And then we set each factor equals 0, we solve for x. When you solve for x, we are done because x is already alone. But in our case, when is got the 2 factor, set each of them equals 0, try to solve for x. We don't have an x alone. We have x in the power. So after you get here, we still have to do one more line, get rid of the power, and then we have x alone, just like this. So you're doing the same thing here, but instead of having x as our variable, we have the middle factor as our variable. The middle term, sorry, the middle variable. Clear? Let's do one more together. We have x to the 2/3 minus 4x to the 1/3 equals 5. We have a problem here, right? What do you want to see? 0. Do you have 0 on one side? So what is our first step? Subtract the 5. So we have x to the 2/3 minus 4x to the 1/3 minus 5 equals 0. And now we are looking for 2 numbers. Multiply to 5, combine to 4. 2 numbers, when you multiply, you get -5. When you add them, you get -4. Good job. -5 and +1. So we split our -5 into 2 pieces, -5 and +1. We want to do the same thing for x to the 2/3. Split into 2 pieces so that when you combine them, we'll get x to the 2/3. So 1/3, x to the 1/3 and x to the 1/3. So when you put them together, they become x to the 2/3. So we found our 2 variables. We are happy. What do we do next? Set them equal to 0. X to the 1/3 minus 5 equals 0, x to the 1/3 plus 1 equals 0. We need to add the 5 and subtract the 1. So x to the 1/3 equals 5 and x to the 1/3 equals -1. We're almost happy, but not all the way happy because our x is not the 1, is the 1/3 power. So what can you multiply 1/3 by so that it becomes 1? Good job. So we multiply both sides by 3 and 1/3 3 cancel out. We have our x alone. And now all we have to do is find what is 5 times 5 times 5. 125. So this is one solution. And -1 times -1 times -1. -1. The exponent rules. -1 to the any odd power gives us -1 back. Now do you feel it's easier than the first one? Great. So all the examples we have in this section, most of them follow this, just factor and solve. So go ahead, try the next one. The same concept. You're breaking x to the 4 into 2 pieces, 36 into 2 pieces. So which two numbers multiply to -36 combine to -5? Sign. The bigger factor has to get the middle side. So 9 has to be negative because of the middle sign. That means your 4 has to have what? Positive sign. So 36 becomes 9 and 4. Now x to the 4. How are you going to split your x to the 4? X squared and x squared. Great. If you observe, this is actually a perfect square, right? X squared minus 9. So we can factor this more. What two factors we get from this? X minus 3, x plus 3. And this is not factorable, so just leave it alone. X squared plus 4. That means instead of 2 terms, we actually have 3 terms, 3 factors. We set each of them equals 0. X plus 3 equals 0, x minus 3 equals 0, x squared minus plus 4 equals 0. We'll subtract 3 here, add 3 here, subtract 4 here. So x is -3. We are done. X is +3. We are done. And here we have x squared is -4. We are not done. We are not looking for x squared. We are looking for x. So what do we do next? From x squared, if you want to get x, square root. square root and square cancel out. We're supposed to get absolute value of x, but instead of writing absolute value of x, we write only x. But what do we write on the other side? Definitely 4i, 2i. But see, we didn't write the absolute value. Instead of writing the absolute value, what do we write? Plus minus 2i. Anytime you can square root and square, they cancel out. And for variable, we're supposed to have an absolute value. Absolute value means whatever we have inside, that thing, the result we want to be positive. So either we do this or we do plus minus.
X plus 3, x minus 3, x squared plus 4. We do the same thing, it's x squared minus x.
But this is plus. For plus, there is no rule. This is difference of perfect squares. Difference, not sum. For sum of perfect squares, there is no rule.
So plus 9.
Difference of perfect square is factorable. Sum of perfect square is not factorable. Okay. Does it look familiar? X to the 4 minus 81 equals 0. We don't have 3 terms, right? If we had 3 terms, we could factor that way. For 2 terms, what are the possibilities we have? And then? Fourth root. But you're going to lose 2 solutions for that. Difference of perfect square. Remember the chapter 6 or somewhere we learned if we have 2 terms, there are only 2 choices you have to factor in. Either GCF or difference of perfect squares. GCF we don't have any here. That means our second hope is difference of perfect squares. It means we want to rewrite this as something squared minus something squared. This is what we want. We write that into difference of 2 perfect squares. So how can we rewrite x to the 4? What square will give us x to the 4? X square. And what square gives us 81? 9. Why we did that? Because it's factorable. Anytime we have difference of perfect squares, we can factor. So what are the 2 factors we have? These are our bases, right? How do you factor difference of perfect squares? We add the 2 bases and we subtract the 2 bases, right? Just like we did here, x squared minus 9 is x squared minus 3 squared. So it was x plus 3x minus 3. And here we have x squared minus 9. Sorry, x squared and 9. So it's x squared plus 9 and x squared minus 9. You add the 2 bases and you subtract the 2 bases. We did this before. In your second exam or something, I don't remember. Now this is plus, so we cannot do anything. So bring it down. But this is minus. We have x squared minus 9, which is x squared minus 3 squared. So what 2 factors we get from here? X plus 3, x minus 3. Which one?
You carried out x plus I.
Yeah, good observation. Thank you. I forgot my square. X squared plus 9, and then x plus 3 minus 3. So x squared plus 9 equals 0. X plus 3 equals 0. X minus 3 equals 0. subtract 9, subtract 3, add 3. So x squared is minus 9, x is negative 3, which is done, x is positive 3, which is also done. But what do you have to do for the x square? Square root, square root. So x equals plus minus 3 and I. It's I because it's a negative under the square. Anytime you have negative under the square root, it's I. And we already know why, because negative 9 is negative 1 times 9, and negative 1 under the square root is I. Negative 9 under the square root is 3. So we have 4 solutions. We have x equals positive 3, negative 3, positive 3i, negative 3i. 4 solutions. And guess what? In the final, you'll have at least one of these. Either from the 4th power or from the other weird looking powers, like 2/3, 2/5, those things. Usually they like the 4th power question. So either they'll give you the left one or the right one. Okay, then how many more weird looking we have? One more. X to the negative 2 minus 9x to the negative 1 plus 20. So if you multiply negative 1 times 2, do you get negative 2? Yes. That means, yep, we can try using quadratic methods. Can you think of two numbers multiplied to 20 combined to 9? Good. Negative 5 and negative 4. So how are you going to split x to the negative 2? X to the negative 1. And then try solving it. Now, these are not difference of squares. These are negative powers. X to the negative 1 and x to the negative 1. When you combine, then you get x to the negative 2. So these are the difference of squares, but these are just negative powers. So you set them equal to 0 for individual, each of them individually, and then from there you solve for x. And now we have only one tiny bit problem. Instead of positive 1, we have a negative 1 power. Good. Remember the exponent rule? X to the negative 1 becomes 1 over x. So we have 1 over x equals 5 and 4. But we are not looking for 1 over x. You're looking for only x. So what do? Remember the working together problem we did in our last example? At the end, if you have 1 over x equals something, how do you solve? You can cross multiply or you can simply flip. Because our x is already alone, right? It's already alone. There's the only problem is on the denominator. So in order to solve that, all you have to do is flip. You bring this on the top and it goes on the down, on the bottom. So if you flip 5, it becomes what? 1/5, not -5. You're flipping. And if you flip 4, it becomes 1/4. Question? Now, all these examples we did, they were factorable. So we factored and we solved. But not every question is factorable. For example, this one, I'm not going to the details. I'm just telling you the method. So this is from your homework. And also quiz. This is not factorable because we have two numbers multiplied to 4 combined to 9. It's not possible, right? So you cannot factor. Since you cannot factor, you have two choices. Either use quadratic formula or complete the square method. So it's up to you. Whatever you do, if you use quadratic formula, previously we had x equals negative b plus minus square root of b square minus 4ac over 2a. For example, we don't have x. So instead of x, what y with the square. See, all these factors we did are factored had the middle term, right? In our factors. All of them, if you observe, we have x squared, the middle factor. X squared, it doesn't have any middle factor. For example, this, x to the 1/3. The previous one, x to the 2/3, 1/5. So our variable was the middle one, the middle term. So here, when you try to use quadratic formula, instead of x, your variable should be the middle one, y squared. But why? So even though you have y squared equals negative b plus minus square root of b square minus 4ac whole thing over 2a, you have to take the square root again. So that the square root and square cancel out. And you have your y single. Now this should be your final answer. And then all you have to do is replace A, B, C, and C. So you have 4 solutions. Sorry, my bad. I'm missing a plus minus. So y equals plus minus square root of negative b plus minus b square minus 4ac whole thing over 2a. So this should be the final answer. And your 4 solutions: plus, 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 minus, minus, plus, minus, minus. The answer should it's too big. Still too big. Still too big. One more. Okay. So 1, 2, 3, 4 solutions. This will not be in the exam, but these are in my MATLAB. So you have two choices: either do them manually or just use format those things, AI. Question. You get the same result anyway. But I'm not going to do them because this will not be in the exam anyway. So this is annoying. I don't want to waste our time. Instead, let's go to the 11.5 and 6. Now 11.5 and 6, they talk about all about quadratic. To begin with, we start the two formats of quadratic. There are two formats. One is standard, one is general. The standard form is a and the next minus h whole square plus k. This is the standard form where we have h. Now we love the standard form because you can see our vertex. The vertex is the opposite side of the inside and the same thing with the outside. So h and k, when you put them together, they give us our vertex. So h is the x value, k is the y value. What is vertex? Vertex is, if you have an upward parabola, this is your vertex. If you have a downward parabola, this is your vertex. Okay. And why do you care about vertex? Because see, vertex give us either the minimum or maximum. And in our life, we want to find out what is minimum and maximum in most cases. For example, if you're selling something, you want to know what is the maximum profit you can get from your selling. But if you're buying something, you want to know how much is the minimum money you can spend to buy something, right? This is the real life scenario. So we care about minimum, maximum most of the time. And that's why we care about vertex. And that's why we like the standard form, because it tells us our vertex. Now, quadratic equation is symmetry. It means you can split them into two pieces and you get the same equal pieces on both sides. Equal piece on both sides. So if you split it through the vertex, the left of the vertex should be the same as the right of the vertex. And when you split, we get an axis of symmetry. Our axis of symmetry is the x value of your vertex. And since it's a vertical line, so its equation is x equals the x value of the vertex. The second format is general form. There's only one reason we like general form. It tells us what is our y-intercept. We don't have to do any math to find out the y-intercept. The y-intercept is a constant. And if it's factorable, then we like the general form to find the x-intercept. If it's not factorable, we don't like it. Generally, we since we don't see the vertex, so we have to find the vertex. So use a formula. The x value of the vertex is negative b over 2a. So we have to replace a and b into this formula, and then they will tell you what is our h. To get the y value, we replace this into the function, and it's solve for y, and we get the y value of the vertex. So this is our x, this is our h, and this is our k. And again, this is a symmetry is x equals the x value of the vertex. Now we already know this. If your leading coefficient is positive, then we have an upward parabola. Like if you have x squared, blah, 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 we have an upward parabola, and we get a minimum in our function. If your leading coefficient is negative, like let's say negative x squared, then we have an upside down parabola and we get a maximum. So this is max and this is min. Now about domain. Since parabola has a polynomial format, so its domain is everything, means we can replace any number with x. So we have y equals ax squared plus bx plus c. We can replace our x with any numbers. So that's why our domain is from negative infinity to positive infinity. Means all the x values are replaceable here. But for range, there are two options. If you are working with an upward parabola, let's say you have a parabola here. Remember, range is the y. So for upward parabola, your range is the y value of your vertex to infinity. So from k to infinity is your range for your upward parabola. But if you are dealing with an upside down parabola, let's say here, then your range is from negative infinity to the y below the vertex. Negative infinity to the k, so this is your k. And this is your k. So negative infinity to k if you have an upside down parabola, but for upward, it's from k to positive infinity. The y's. For x's, is same. The x value runs from negative to positive infinity. The domain is everything. Now, how do you find x-intercept? If your format is general format, you factor, you solve if it's factorable. If it's not factorable, you have two choices. Use the quadratic formula or complete the square. And then solve. But if you have standard form, like this one, all you have to do is set the y equals 0 and solve for this x. It means you need to get rid of the k, the a, the square, and the h. So you need 4 steps to solve for x here. And it doesn't matter which format they give you to find the y-intercept. You set all the x equals 0 and you solve for y. So y-intercept has only one method, but x-intercept, depending on which format you have 3 methods. Either factor, complete square, or quadratic formula, or just solve for x. Any question? No? Let's stop here. We are going to do one example. We're going to do few examples tomorrow. And then we are going to do transformation. And what else? After transformation, we are going to go other way around. From parabola, figure out your equation. And then you're left with only one more section. Yay! And then you'll do a review. Oh, so not one more, 2 more sections. Let me see who was here today. Today is 5-1. Eliza was here. Fabricio was here. Sergio here. Miley here. Oliver here. Himadri here. Mustafa here. Jacqueline here. Jain here. Anaya here. Atsiri. Hitlali was here. Saida was here. Muhammad absent. Fernando here. Danielle here, Jeremiah here, Camila, Julia.
One.